What exactly is a cloudburst, and how does it happen? How can a rain cloud holding tons of water remain in the sky? Why does hail sometimes fall? How is artificial rain created through cloud seeding? Let's explore answers to these questions through this video. A cloudburst refers to a phenomenon where a large amount of rain falls in a very short time over a small area. Since it occurs within a brief period, it can cause flash floods. Before understanding how a cloudburst occurs, we first need to understand what clouds are and how rain forms from them. There is always a small amount of water vapor in the atmosphere, but, like regular air, water vapor is transparent to visible light. It doesn't block or scatter light. Therefore, even though water exists as vapor in the atmosphere, we cannot see it. However, we can see clouds, which means they contain not just water vapor, but also water in liquid or ice form. These forms of water can reflect, scatter, or block sunlight, making clouds visible to us. Naturally, a question arises. If vapor is the gaseous form of water and can float in the atmosphere, shouldn't water in liquid or ice form fall down due to gravity? When sunlight streams into a room through a window, we can see tiny dust particles floating in the light. Dust is solid and has mass, so it should fall to the ground due to gravity. But have you ever wondered why it floats? Because it's so small, its surface area is large compared to its mass, so air currents affect its movement more than gravity. Even a slight air movement can keep these particles suspended in the atmosphere. The same phenomenon applies to clouds. Inside the clouds, each droplet, or particle, is about 5 micrometers in size. At such a small scale, the motion of atmospheric air has a greater impact than gravity. In most cases, there is a slight updraft within clouds, a small upward movement of air. This updraft is enough to hold up these tiny ice particles or water droplets, preventing them from falling. Let's understand how water vapor in the air transforms into these tiny water droplets. There's a process called evaporation, through which water can turn into vapor even at normal atmospheric temperatures. For instance, when we hang wet clothes to dry, the water in them evaporates. However, there's a limit to the amount of water vapor the air can hold, known as the saturation point. When the atmosphere has absorbed the maximum vapor it can hold, we say it is saturated. This saturation point depends on the temperature of the air. For example, if we keep adding salt and stirring, initially it will dissolve, but as the salt amount increases, it will eventually stop dissolving. That's the saturation point. And with increasing temperature, even more salt will dissolve. However, if we let the water cool, the excess salt will start settling at the bottom of the container, meaning the solution begins to push out the extra salt as it cools. Similarly, air temperature decreases, it allows more water vapor to condense into liquid. This process is called condensation, where water vapor transforms into water droplets. For example, when we place a cold glass of water or ice outside, we often notice condensation forming on its surface. This happens because the air close to the cold glass cools down, and any excess water vapor in the air condenses onto the glass. For condensation to occur, a surface is typically needed, as we observe on the glass. However, with clouds, there's no such surface high up in the sky. As warm, moist air rises, it cools for various reasons. Higher altitudes generally have lower temperatures. Also, as air rises, the pressure decreases, causing the air to expand and cool. As this moist air cools while rising, its ability to hold vapor decreases until it reaches saturation. When the temperature drops further, the excess vapor condenses, but there are no large surfaces in the sky to facilitate this process. Instead, condensation occurs on tiny particles in the atmosphere, such as small dust particles, salt crystals, pollen grains, smoke particles, and ash. These particles are extremely small, often less than a micrometer in size, and this acts as a surface for water vapor to condense on. The particles on which water vapor condenses to form visible clouds are called cloud condensation nuclei, CCN. When transparent water vapor in the air condenses on these CCN, tiny water droplets only a few micrometers in size form. Although clouds contain small water droplets, these droplets don't fall as rain. Moreover, if the amount of water vapor in the cloud is relatively low, the air will no longer be saturated once a small amount of condensation occurs. When this happens, further condensation ceases, preventing the tiny droplets from growing larger and causing rain. However, under certain specific conditions, these tiny droplets can start to grow larger. One reason for this is if the cloud rises to a higher altitude where the temperature drops further, or if colder air from another source mixes with the cloud, causing it to cool more. At a certain point, the updraft within the cloud can no longer hold up these larger droplets, causing them to gradually fall. As they descend, they continue to merge with other droplets, growing into larger drops. Eventually, these large drops gain enough weight to fall to the ground as rain. If this entire process occurs in a much colder atmospheric layer, the vapor may directly condense as ice crystals. This difference can lead to various forms of precipitation, such as snow or hail. When the temperature is extremely low during these processes, instead of forming water droplets, ice crystals grow. Eventually, when these ice particles fall, they descend as ice chunks instead of water, which leads to hail formation. For a cloudburst to happen, 3 conditions need to align. Imagine there's a large rain cloud containing a substantial amount of water vapor along with sufficient cloud condensation nuclei, CCN. Due to these factors, many small water droplets exist within the cloud, but they aren't large enough to fall as rain. Further condensation must occur for these droplets to grow large enough to initiate rainfall. Now, suppose a rapid cooling event affects this cloud. This can happen in various ways. Cold air may suddenly mix with the cloud, causing a drop in temperature, or a fast-moving wind encountering a mountain can quickly rise, carrying the cloud upward and cooling it rapidly. When a large rain cloud with significant vapor content undergoes sudden cooling, extensive condensation takes place, resulting in a cloudburst. Now let's talk about cloud seeding. Even if there's enough vapor and the air temperature has dropped to the saturation point, if there aren't enough CCN, condensation won't effectively occur. In such cases, artificial CCN introduced into the atmosphere, process known as cloud seeding. Cloud seeding relies on the presence of sufficient water vapor in the air as well as cool conditions conducive to condensation. When these factors align, materials like silver iodide or dry ice are introduced into the atmosphere, typically from an airplane or other sources. These substances act as CCN, triggering condensation. If the clouds contain enough vapor, this process can lead to further condensation, ultimately resulting in rainfall. This is the essence of cloud seeding. Thanks for watching.